Hello, and welcome back to this tutorial. This one will be a quick one, be about 10 minutes. And I quickly want to go over what we did in last video with the pointers. Now, when we will start doing C++, there'll be a better explanation on how things work, right, in terms of memory, and you'll see it in terms of code of why we're doing pointer logic. But in the last video, right, we went over how the whole point of kind of like chasing down the original value to the base address, right? Because it's like most of the time the value is not going to be the final value. It'll be a pointed value from the start, right? It's not like you start the program and in the main there's a struct and it's only that integer, right? Programs don't work that way. Programs are worked by kind of object, at least in C++, because it's an object-oriented game or language. So what happens is we create structures or type definitions or little boxes that contain sections. And these are the sections, right? So this is a box. Think of it like this whole thing is a box or a structure. And these are the sections of it. And some of these sections are mailboxes to other sections of other structures, right? So think of this might be like health, this might be ammo, this might be whatever, but this is a passageway into the next section, into the next structure. And then this one has a passageway in the third column, right? And this one has a passageway in the first variable or data structure or data type, right? And it will point here and it'll give you instructions to go here. Now, to give a better example how it works with code, here's a simple example of how this would work in a game. So assume this is some game about like a city and you drive a car, right? You have your own garage, you have vehicles inside the garage, and inside the vehicles there's like horsepower and how much fuel it uses and the type of like, right, you know, the color of the vehicle, maybe that could be the type, right? So the idea is, right, comparing to what we did in the last video, this is how it would represent in code sense. Like, let's say somebody was coding a game, how would this be represented? So the idea is very simple. It's the same idea, but here is how a programmer, when he's programming a game, would lay it out in terms of C++, right? So it's the same idea, right? It's the same box, right? Let's assume this is the value you're looking for. And in this case, we're going to be looking for fuel efficiency, right? And the structure starts, right? Even though it's structure engine, it starts at the integer. An integer, when we get into C++, is 4 bytes of memory. The usual compilers, when you compile a game, an integer will be a size of 4 bytes. And you can see that from the integer, and when the double starts, the offset is 0, 4. And what you can see is that since the offset is 4, we know that the integer, I guess in this compilation, would be the size of 4. Now a double is a bit larger. Now since you see we're not going by 1, 2, 3, 4, even though from 0 to 4 you see 4, this is C. So if you want to quickly go over what it means, and let's do a color, let's go blue. Right, we start at 0, right? Then it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll go into A, right? B, C, D, E, and then finally F. Now you can even count them. We have 1, 2, right? So we are from 0 to 9, we have 10. And from A to F, we have 6. So that would be a 16 byte, right? That would be a 16 base number system. So from here, from 4 to C, right? We start at 4. So we are here. And then we're trying to get to C, which is right here. So how much is that? That's 1, 2, 3, 4, 5, 6, 7, 8. So we now know, just by looking at how the memory works, that the double to character, right? This section, the gap, the amount of memory that is needed for the structure to occupy is 8 bytes. So think of it like this, right? We have a section. Right, of integer, and it will be 4 bytes, right? And we'll do it like this. Oops. Then we also have a double, which is going to be 8 bytes, and let's do it like this. Let's go to double. Right? It'll be 8 bytes. Oh, okay, I'm doing it. I'm doing it the wrong way. From here, it'll be double. Right? And then we also have a character, char, right? This will be a character. And a character, or char, is actually 1 byte. So that would be, let's say it's half of this and half of this. Right? And we'll make it orange, right? But we have a total of 10 of these, right? We have a total of 10 of these. So how much? So let's see. Okay, let's see. What can we make with this, right? We do something like this. And let's combine them, right? And I'll make it look a little bit more pretty, right? So this entire section right here is your one instance of engine struct, right? This is one instance. So basically, in this code, it's just defining what would be an engine, right? It'll be a part of an integer, it'll have a double, have a character, but in the code, you have to specify, you have to actually create it. This is just you making a blueprint for the engine of like a structure of a box that will contain all these things. But in the code, you actually have to yourself be like, hey, I want to create Ferrari engine. I'm gonna create an engine, right? I need to create an engine. Okay, well, I have this structure that I made. It's a blueprint of engines, and I'm gonna name it Ferrari engine, right? Or my engine. We have to be like engine, my engine, Ferrari engine. I know it sounds a little bit redundant, but it's basically, this is just a DNA blueprint. Let's say a DNA of a human, but the human has to be created. You're the one who has to actually do it, right? You, as a programmer, the coder who's doing it, has to create the structure. You create the blueprint, and then you yourself, from the blueprint, create instances of that object. So you can create Ferrari engine, you can create BMW engine with different values, you can create Volkswagen engine, right? So you have to look at it in terms of blueprint, right? This just gives you how the structure works. But when a programmer or a coder for a game creates these things, you have to not only look at the instance, right? Because you can have multiple engines, right? And they can follow the same pattern. So in a way, it actually makes your life easier. Because if you can find one instance of an engine and you can see how these patterns go back, if you find a second one, most likely they'll take the same pattern backwards, right? So you can actually do cheats for multiple engines at the same time. Or you can do generic cheats where it doesn't matter which engine it is, right? Even if there's an update and somebody adds a new engine, your cheats will still work and it will still pool the new level of engines or data strings. So basically, going back to the topic, this is how it all kind of looks from the programmer's perspective, not from a reverse engineer's perspective, but from a programmer's perspective. So remember how we did, hey, this pointer, right? So when somebody creates, let's say, engine, right? They kind of have to create usually this chain, right? And for example, engine pointer, right? When somebody declares an instance of this entire chain, right? Makes an instance of one, right? Like in the city of New York, in a garage at, I don't know, next to the Empire State Building, there's this vehicle in that garage and it has this engine, right? You created that instance, right? The program says, okay, well, I create this object. It'll be in here, 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 here. It'll be this vehicle, it'll be this engine with these values. He created it. He assigned these values. But this is a blueprint he used to assign these values, type of thing. Well, when he assigned it, right, he probably created an engine pointer, right? It won't be named probably an engine pointer. This is just a way I'm going to structure this. So he might even rename it and be like engine pointer to BMW, right? Engine pointer underscore BMW. But the idea is he will still have this pointer, and it might be even similar name, maybe even different, maybe even sometimes even the same names. You can do this like the exact same names in certain situations, how if they're not referenced or that within the same code. But essentially what they did is, right, they will create this, right? When you create the struct, this will be created for it. They'll be assigned to it. And this will have the address of the structure of the engine that they created for, right? So when they create this, the address will be stored automatically in the engine pointer, just like what we did with the pointers, right? So assume this is like the engine pointer, right here. In reality, looking at this example, this would be more like on the third, right? So assume this is like right here, actually, right? Assume that this box is on the third level, and then you have all these arrows coming out of it. But the idea going back to here is that it does the same function. It holds the address, right? It holds the address to the struct engine, whichever you created, of course. Now, you still don't know where to go to the fuel efficiency, right? And in a reverse engineer's perspective, what you did is you figured out the assembly instruction that kind of gives you the offset 0x04, right? What we had in our last video, and that will actually tell you where to look for fuel efficiency within this structure of the engine. We know it starts like basically when you point to it, it starts at 0x00, but we're not looking for horsepower, right? We're looking for fuel efficiency. So you have to know where this 0x04 is. When you reverse it, you look at the offsets, you look at how the instructions are working in assembly, and what we saw in the last video, this is how you figure out that offset when you go backwards. When you code for the game, the way you dereference it, that's the correct word for it, is you use engine pointer and you use this two characters, the kind of like an arrow, and you essentially point, or it looks like a pointer, really, and you dereference where the fuel efficiency is with the engine pointer. Because when this instance is created, your instance of a vehicle, you assign the pointer, it points to the engine, and it has the value when you created it, it has the information of where the horsepower is, where the fuel efficiency is, and where the type is. It has that reference when you create the structure. If you want to access that structure, you dereference it, the fuel efficiency, and that's how you can find the number that is stored within the fuel efficiency. If you would just write engine pointer, right, it would be the same thing as doing something like this, right? It will just point to the start. It might be correct, for example, for this instance, but it will not be correct for this instance because it will just point to the start of the structure. So you need to dereference it to get the correct location of the memory that you're trying to look for. Now, see how I said that it might still work? that is not a good reason. That is not actually a good sign, because that means it's an unintended way of something working, right? So even though it worked, right, and let's say you created some scenario where you coded and it worked for you, well, this is most likely going to be a bug in the future. It will be an error. It could be exploited, which is something we can even use, right? We can use these type of mistakes to our advantage. But as a programmer on the other side, you want to avoid these type of mistakes. And we'll go into it a little bit when we start coding. But the idea is this is the same thing. This is how it will look like from a programmer's perspective. And we will go basically the same way down the chain, right? We have the engine pointer, vehicle pointer to the engine pointer, right? We'll go back the chain, up to the point of the city, and assume there's another chain right here, right? Assume there's, right, there's another chain, and this is like the base address, right? This is the base address plus some initial module offset. Right? This would be like the start of it. If you want to know how the full kind of dereferencing, let's say we want to start at the city, right? Like we start at the beginning, and just to get to the fuel efficiency, this is how it would actually look like in code, right? It'll be a garage pointer dereferencing the vehicle pointer dereferencing the pointer pointing to the fuel efficiency, right? And that's how you would get the number from programming's perspective. But essentially, this is what you're doing. This is what we're doing every time we're trying to find values. All programs, or at least video games in this sense, right? And what we're looking for, video games specifically, kind of work on this principle 99% of the time. Of structures, part of other structures that have pointers. And to think of it, pointers are just kind of like mailboxes, right? They're mailboxes for you to access, right? Think of it like, here's a fuel efficiency pointer to the engine, right? So whatever the engine is, right, vehicle can look into this struct, the instance of the struct being created, and look at all these values. You can create an inverse pointer that looks back into the vehicle. But for the most part, right, we don't really care about that yet. We just care about one-way looking first. And for the most part, you don't need to. And vehicle can see what's inside the engine, right? But the garage can see what's inside the vehicle. And then the city can see what's inside the garage, right? And then if you do the chain that we did from last video, you can eventually see the full chain of going from, let's say, the garage pointer into the vehicle pointer, into the engine pointer, into the fuel efficiency variable. Now, this structure, right, of these bytes and offsets, we will learn as we will do C. So for example, integer is usually 4 bytes, character is 1 byte, bool, if I'm not mistaken, is also bools, if I'm not mistaken, is just a bit in a lot of cases, but I'm not sure. It depends on the okay, we'll go into, like, it depends. I think it really depends on how you can even set it up, how much memory each of these can take. Double is 8 bytes, right? These do vary based on the compiler and your architecture, but for example, if you're using Unreal Engine or Godot or Unreal or like a CryEngine or Unity, right, the open source one, they all roughly work the same way when they compile, right? They're not that different from each other, and they all kind of follow the same standard of how much, an integer will be when somebody codes within their engines. The only time you'll start seeing differences in these is when the program was created by some kind of in-house engine that is, it's not created, this is specialized for something, and they might have different ways they set their integers. Then you'll have these problems. But most games that you see on the market, that you will see, that you'll probably want to hack, do not have some crazy standards or templates that they go deviate and they have different sizes. And even if they do, you don't want to worry too much. It's just something for you to predict when you do reverse engineering. You can figure out, even if it's not 4 bytes, let's say an integer is not 4 bytes, you can figure out eventually, hey, oh, in this case, it's 8 bytes. Because you start to see patterns, you start to see numbers changing, and you'll realize eventually, right, after doing some trial and error, you'll run into some roadblocks. You realize, oh, for some reason, this game uses a different format for its memory, uses more memory or less memory, right? This is more useful in, like, let's say, kernel level. Anti-cheats is more useful in when you're trying to reverse engineer like DLLs, you're trying to reverse engineer drivers. But for games, this pattern, right, and rough standard of how bytes work is how they do it. Okay? Hopefully that kind of gives a better understanding. I'll guys see you in the next step for the cheat engine. And hopefully this kind of cleared up some maybe confusion of how pointers jump and how it looks from an actual programmer's perspective. Okay? All right. Thank you guys. I'll see you in the next one.